So moving on to our next example, section 7.1, part 3. Example 3 says, an experiment consists of tossing a coin 3 times, observing the resulting sequence of heads and tails. Part A is asking us to describe the sample space. So for your textbook, the word describe really means list. So they're asking me to list the sample space. Well, before I go to do that, it would be nice to know how big my list is. So I'm going to go back to our multiplication principle. We're tossing a coin 3 times. There are 2 possible outcomes for the first toss. That would be a head or a tail. 2 outcomes for the second toss, and 2 outcomes for the third toss, giving me 8 possible outcomes. So when I'm done with my list, I better have 8 things in my list. So I'm fairly systematic about this. So I'm going to do S is equal to. The first thing I'm going to do is keep them all the same toss. So I'm going to do all heads. You can use uppercase. You can use lowercase. It's entirely up to you. I'll use lowercase because it's quicker. So I have head, head, head. Now what I'm going to do is take that last head and trade it for the tail, the opposite, or the complement, I guess would be the correct word. Then we're going to rotate that tail through each of the spots. And then I have head, head, or tail, head, head. So notice what I did. 2 heads and a tail, and then I rotated the tail through all 3 of the positions. And then I'm going to come in and now make 1 head and 2 tails. So I'm decreasing the number of heads and increasing the number of tails. So now I have 1 head and 2 tails, and now I'll rotate the head through the 3 spots. And then I'll have tail, head, tail, 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 head. And then finally, we're going to do all 3 tails. Sure enough, when we're all done, we've got 8 listed on the board. And there they are. So again, I start off with all 3 as 1. I switched the last spot, the last toss, to the other outcome, and then rotated that outcome through the 3 spots. I then switched the second to last spot, so that I had 1 head and 2 tails, and rotated the head through all 3 of the outcomes. And then finally, all 3 of the other ones. And it gives me all of them in a fairly systematic approach. Okay, part B is asking us simply to determine the event E that exactly 2 tails occurs. Well, all I have to do is come back up here and look for exactly 2 tails. So exactly 2 tails would be this one, and this one. So I'm going to relist the head, tail, tail, the tail, head, tail, and finally tail, tail, head. Part C is asking me to determine the event that at least 1 tail appears. At least 1 tail appeared. Well, at least 1 tail, well, that would be all of them but this one. So they're asking me to list all of those guys. So at least 1 tail would be tail, head, head, tail, head, tail, head, tail, head, head, and then we'll come back to these guys. Head, tail, 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 head, tail, 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 head, and finally tail, tail, tail. So 7 out of the 8 outcomes for that. So again, if you can list the sample space, then the rest of it's fairly straightforward because they're asking for subsets of that sample space. Here, our next example deals with a pair of dice. So just in case you're curious, die is singular, meaning 1, and dice is 2 or more. So in this case, we're doing a pair of dice in example 4. So an experiment consists of rolling a pair of dice and observing the number that falls uppermost on each die. So we want to, again, describe the sample space S. So before I describe it, I want to figure out how many it is. So we're tossing a die twice. There are 6 possibilities on the first toss, 6 possibilities on the second toss. So there are 36 outcomes in our sample space. So S is going to be equal to, I'm going to do 1-1. You can write it in numerous ways. I'll do 1-1 because that's the simplest way to write it. So that means 1 on the first die, 1 on the second die. Then I would have a 1-2, a 1-3, a 1-4, a 1-5, and a 1-6. So there's 1 on the first die, 1 on the second die. What you can think of this as being is 2 colors of your die. So maybe a red and a green die. So 1 on the red die, 1 on the green die, 1 on the red die, 2 on the green die, 1 on the red die, 3 on the green die. And I think that helps with why we're writing in this way. We're going to come in and do 2-1. So 2 on the red die, 1 on the green die, and so forth. And then we'll do 3-1. And hopefully you can start to see how we're going to end up with those 36 by the time we're all done. Sorry, it's getting a little sloppy there. 1, 2, 4, 5, 6, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And then finally, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And there they all are. So there's all 36 outcomes. Whew. Okay, now part B actually pulls out some interesting traits in this chart. So part B says we want to come in and let the event E sub 2 be the event that we get a sum of 2 as our possibility. Well, when I look at this, the only way to get a sum of 2 is this guy right here, the 1, 1. So E2 would simply be 1 dash 1. E sub 3 would be the sum of 3. Well, when I go look for the sum of 3, I'm going to notice that they're this diagonal right here. So that would be the 1, 2 and the 2, 1. There's only 2 ways that occur. E4 would be a sum of 4. So for us, that's this diagonal. So that would be the 3, 1, the 2, 2, and the 1, 3. You can start to see the pattern. We'll do one more. E5 would be this diagonal sitting through here. So that would be the 4, 1, the 3, 2, the 2, 3, and the 1, 4. And again, because it's a set, it doesn't matter in what order you're listing it. 4, 1, 3, 2, 2, 3, and 1. So sure enough, the next diagonal would be the 6s. The next diagonal is the 7s. The next diagonal is the 8s. The next diagonal is the 9s, the 10s, the sum of 11, and the sum of 12. So you can see those diagonals sitting in there, and they really do help you concentrate on getting the correct answers. The other thing to point out before we move on with this is the doubles, because in our future, we're going to know the doubles. And you'll notice that the 1, 1 only appears once, the same with the 2, 2, the 3, 3, the 4, 4, the 5, 5, and the 6, 6. So double only appears one time as an outcome.